Okay, so for chemical element, this chapter is mainly elements, compounds, and mixture, and that all substances which are composed of only one type of element or one type of atoms, right, are what we call an element. Okay, so in this case, right, there is three main items they need to know to identify. One is this, second is compound, and third is mixture. Each of it, the definition you have to remember, and they tend to ask you to compare between a compound and a mixture. So what's an element? An element is a particular substance, right, which are only made up of one type of atoms. Okay, and these are mainly found in the periodic table. Okay, now for this kind of items, right, you will know that these are actually very unique. And how is it classified is that an element, right, they tend to be represented by a symbol, a chemical symbol that will only contain one capital letter. That means the first letter must be a capital letter, and then the subsequent one, right, the subsequent alphabets will not need to be. But however, so this is how you actually go about recognizing it, and they are pure substance that cannot be broken down into any simpler substances by chemical methods. So this is the definition of elements in the event the exam they ask you to label. Okay. Second thing is that what is this keyword called pure substance? So pure substance, right? There are a few ways to identify them. That means there are no other substance that it contains, and this can be represented by a fixed melting point or boiling point. Okay, it would not have any form of fluctuation. And in nature, elements can usually exist as a monoatomic element. In this case, it only represent only by one atom, or it can be a molecule. Molecule are basically particles that can consist of two or more particles, but they have to come from the same element. And this is where they are actually chemically combined together by either a covalent bond. Okay. So what we can see is that elements, they can be represented in this form. You have helium, hydrogen, ozone. So things that you can find in the periodic table, they tend to be element. Things that you cannot find on the periodic table, they tend not to be element. There are of course a few special molecule names that you have to remember, like like ozone. Okay, which is also considered as an element, but it's a molecule of element. Why? Because it's made up of 3 oxygen atoms. Okay. Then of course you have sulfur and the rest. Now for the elements, right, they tend to be 2 types of elements, the metal and the non-metal. So your metals are generally your group 1, 2, and 3 of your periodic table. Whereas for non-metal, they tend to be group 4, 5, 6, and 7. Your group 0 is actually known as your noble gases, and each of it has its own unique property in the sense that they have their own physical property, melting point and boiling point. Okay. So examples of metal, they tend to be very shiny. They have very good conductors of electricity and heat. Malleable means they are able to be bent and without breaking. Ductile is whereby if you pull and stretch it, like when you're making pasta, it doesn't actually break apart. High density, so in a sense they are able to sink in most of the solution that it contains, and at a high melt, and it of course have a very high melting and boiling point. On the other hand, if you look at non-metal, they tend to be brittle. Brittle meaning you are able to break easily. And of course, low density. Low density, sometimes depending on the density of water, it will most probably float on water. Okay, and so on and so forth. Next, the second one we look at is actually compound. So what are compounds? Compounds are also pure substances, but it's mainly made up of atoms of 2 or more elements that are chemically combined together. The keyword here is chemically combined together. That is what distinguishes it from a mixture. okay, and that they are mainly made up of two or more different elements. If they are the same, right, it's most probably not a compound, it will be an element. Okay, and of course they are also pure substances, meaning they will have a fixed melting and boiling point. Now, in order to form such compounds, you tend to either release energy in the form of heat, or you absorb energy. These are actually important so that you are able to actually use the energy to overcome the intermolecular forces of attraction. So if you take in heat from the surrounding, resulting in decrease in surrounding temperature, it's actually endothermic. However, if you release heat to the surrounding, it will be an increase in temperature, and that will be exothermic reaction. Okay? So a compound, so in that sense, these are the physical properties and chemical properties of the individual elements, and that a compound is made up of atoms of different elements that are chemically combined in a fixed ratio. So the constitution elements in a compound will have a fixed proportion by mass, which is annotated here. So what does it mean? Water is formed when you have two hydrogen atoms that are chemically joined with one oxygen atoms, and then the ratio will always be 2:1. So the water in the ocean, the water in the tap will also follow this chemical formula of H2O, which has two hydrogen atom to one oxygen atom. Okay, same for methane, which is another example for gas. So that's what they meant by fixed ratio. So when two elements, a metal and non-metal, combine together, you usually form an ionic bond, and it ends off with the salt having an IDE. Okay, this is more for naming, which we will go through more in the chapter of chemical bonding. Okay, so each of these compound will also have their own unique physical property, and they don't actually follow their individual elements before that. But of course, being a pure substance, they'll have their own fixed melting point and boiling point. So atoms of different elements in a compound, usually you can be identified by different size, different shape, even by different patterns or color on it. Okay, so this one is more towards if you are given a diagram, you will be able to identify it, which I will go through with you one example later. Okay. Now the third one, the last one, is actually the mixture. So for a mixture, right, the mixture consists of different parts that are substances that are not chemically combined together, and they can only be separated by physical methods. Physical methods are those that we have already went through in the chapter of separation technique. For example, filtration, simple distillation, fractional distillation, paper chromatography. All these are physical methods, and you cannot actually separate a mixture. Okay? You can actually separate using you can actually separate a mixture, but not compounds. Okay? And this is because it has not chemically combined together, meaning the bonds haven't really formed together yet. Okay, and so we are able to have three different variations of it. You have mixtures of elements where you have two or more different elements that are together. You can have a mixture of elements and compounds. For example, these are actually your mixture, and the one in yellow is actually your compounds. So again, you can also have a compound. Okay, so these are the things that you may want to take note of, and that each of the substance in a mixture will retain its physical and chemical properties. Okay, in this sense, right, because they are not chemically combined together already, right, so they would generally follow the properties that is similar to its original physical element. Okay, so when the substance in a mixture, they retain their physical property, because the formula of formation of a mixture does not involve any chemical reaction, and therefore there is no chemical change that takes place. A mixture does not have a fixed composition by mass. So in the sense, let's say the air, the proportion of oxygen in this room is very different from the proportion of oxygen in maybe another room, because mixtures are not binded, you see, by forces. They are interwinded. They can actually move around freely. So the composition of a mixture is not fixed as compared to compounds. Okay, furthermore, pure substance is usually contaminated with mixtures, and this is an example with this is also an example with mixtures where they are not actually pure substance. They vary because they contain other forms of molecules, and this would actually affect their melting and boiling point. First of all, there will be variation, but more importantly, with mixture, with impurities, right, your melting point, right, will be below. You reduce the melting point. Okay, and the other one is boiling point is actually above. So what this means is the difference, the gap between the melting and boiling point will actually increase when there is impurities. So having more impurities, you have the lower the impure substance will melt below its melting point. So these are some of the things to take note of. And examples like alloys, they are very common mixtures. Air is another one. Your seawater is another example of mixtures where it contains both salt and water. Okay. Last but not least, you will need to know the difference between a compound and mixture. Generally in exam, they will ask you to list down 2 or 3 of it. One of the most simple one that I tend to like is separation, melting point, boiling point, and composition. Where composition is basically, we can see that the atoms are of the same fixed ratio in a compound, whereas for mixture they do not, they vary. Melting point is because compounds, they are meant to be pure substances, and therefore they actually have a fixed boiling point or melting point as compared to mixtures which are not pure substance. And not being pure substance, you have a varied melting point. And because compounds, they are already chemically combined together, you cannot use physical methods to separate them. You have to only use chemical methods. However, for a mixture, you can actually use physical methods to separate them. Properties wise, because they are already chemically combined together, you change the properties of the compound. So it doesn't follow its original or constituent elements as compared to the mixture which still follows it. Because the mixtures, they are not really chemically combined yet. The particles are still on their own. It's just like mixed together only. Therefore, you can actually retain it. Then, of course, formation, compound involves chemical reaction, whereas mixtures do not involve any form of chemical reaction. Okay. Now, one common example of a question, right, is something like this, where you will need to know how to identify an element's compound mixture. So what we can do is I would use the habit to actually identify any patterns. So in the sense, like, okay, over here at C, we realize that there is actually only one pattern. So I'll draw a square box, and within it, I could see that they are all made up of the same shape or size or even color of the particles. So this must be an element. So if I do for the rest, you just have to circle all the patterns available. Okay, this is one by itself. This one, this one, this one, this one. So this simple exercise. So anything that has more than 2 circles, right, automatically you can assume it to be a mixture. Okay, so it's a mixture. Whereas those that only have one circled area, you have to even break it down further to see what is the particular element, the pattern. So this one only got one particle, right? So this is actually an element. Only one, so it's an element. Here got 2, so it's a compound. 2 different shapes. This one got also 2, so it's a compound. And this one got 1, so it's an element. Yeah. Next, what kind of mixture is this? Now, because by itself it is 1, so it is actually an element. and this is a compound. So this is a mixture of elements and compounds. For this one is both are compounds because within it contains two different kind of particles combined together. So it's a mixture of compounds. You prioritize the word mixture first. Then the next one is these are both elements because same particles shape. So in this sense, they are a mixture of elements. And last but not least, this is an element, compound. So it's a mixture of elements and compound. Yeah, so that is all you need to know for elements compound mixture. This is quite a relatively short chapter, so hopefully you are able to understand this better.